Lathes can be used to make a lot of different things, but before you can operate one, you need to have a basic understanding of what the features are and how they work. And these features include the tool post, the compound, the apron, the tailstock, quick change gearbox, the spindle or collet in this case, the thread dial, reverse feed lever, the power feed clutch lever, threading or half nut lever, the power feed selector, Longitude hand feed wheel, cross feed hand wheel, the back gear lever, and the back gear hub. All of these make up the primary features on this lathe and how to operate it. The switch to turn it on and determine which direction the spindle turns is located on the front of the machine. Forward direction, off, and the reverse direction. The forward direction is the most common. It'll be used for cutting. Forward direction, off, reverse direction, off. The back gear is used to run a lathe at reduced speeds or lower RPMs. Put it in back gear, pull out on this lever. You may have to rotate the chuck a little bit. You pull out on the hub. It slows the RPMs down. There's a considerable difference in low gear and what's called the back gear and regular speed. To put it back to normal speed, push this in. You rotate the hub until it lines up. A speed dial is used to set the speed or the RPM of the spindle in both the standard gear and in the back gear. The machine must be running when you're changing the spindle speed. This lever up it, so it moves the carriage back and forth, power feed. Moving the selector down operates the cross feed. The selector must be in neutral when you're engaging the threading or half nut lever. The thread dial needs to make contact with the lead screw in order for it to operate. Loosen the screw and rotate it into position, then tighten it down. The dial will then rotate when the lathe is turned on. When the proper number lines up with the indicator, the half nut lever is engaged and the threading process begins. Since threading takes several passes to complete, the thread dial allows an operator to start at the same place on each pass. The tailstock is used in many applications, and there are many accessories that can be used with it. Things like the dead center, a live center, reamers or drill bits, and even a turret. Perhaps the most common usage is countersinking a hole for a live or dead center. To install one of these, use a quick snap to set it in place. Then slide the tailstock into position and tighten it down. Then crank the handle until it makes contact with the workpiece. Apply firm pressure and then tighten it down with the lever on top of the tailstock. To remove any of these, simply back out the tailstock until it comes out. This lathe is currently set up with a collet system. Collets are pre-sized and they are not adjustable. A 1/2 inch collet for a 1/2 inch rod, 5/8 collet for a 5/8, and so on. Changing the collet is a fairly simple procedure. Start by pulling the handle in to relieve the pressure off the collet. Then press down and unlock the adjusting sleeve. This is internally connected to the collet. Start removing the collet by unscrewing the sleeve. It will take several turns for the collet to come loose. And then simply pull out the collet. Select the collet according to the size of the material you're going to use. Rotate it to line it up and then slide it in. Then use the adjusting sleeve to screw the collet into place. Insert your workpiece and then finish adjusting the collet until it's tight. Then lock the sleeve back into place. Push the handle a couple of times to make sure that it's firm and has a snap effect to it.
Minimum length is about 1.5 inches. Anything less than that might damage the collet.
The quick change tool post makes changing cutters and adjusting them fairly simple. Lock the cutter in place by tightening down the lever. By loosening the nut on the top, you can rotate the tool post to the different angles that you'll need. You can slide it back and forth, but don't slide it off too far because you need to leave enough material to support the cutter and the pressure of the cutter. Then tighten it back down to secure it in position. The reverse feed lever is located on the left side of the power head.
Reverse feed lever controls what direction the carriage moves when it's under power.
And it also controls the direction of the crossfeed. It has 3 positions.
Have up, neutral, and down.
In the neutral position, the lead screw or the screw drive does not rotate and is completely disengaged.
Neutral, it has no power. A lot of hand cutting is done when it's in neutral.
This lever is used to change the direction of the lead screw. The lead screw is what drives the carriage when the half nut or power feed lever is engaged.
This is your power feed. This follows the upper track. This is your half nut lever, and it follows the screw drive.
Okay, when I turn this on in the forward direction,
notice the direction it rotates.
okay. Now, when I shift the reverse feed lever, turn it on in the forward direction,
direction has now changed. As you can see, changing the reverse feed lever changes the rotation direction of the screw drive. While a reverse feed lever is what changes the direction of the screw drive, by switching the lathe and running it in reverse, it will also change the direction of the screw drive. Here the lathe is running in the forward direction. Notice the screw drive is turning in the opposite direction. In this setting, when the lathe is just put in reverse, it also changes the direction of the lead screw. Simply by moving the lever up, we can change the direction of the lead screw even though we're running the lathe in a reverse direction. As you can see, the direction has changed. The purpose of the reverse feed lever is to allow the operator to control what direction the carriage moves or what direction the cross feed moves, regardless what direction the spindle is turning. For example, when an operator is cutting threads on a lathe in the reverse direction, the carriage needs to move away from the head instead of toward it like it would when normally threading. Remember, the on and off switch only controls the spindle direction. The lead screw direction is controlled by the reverse feed lever, and that in turn controls what direction the cross feed or the carriage moves. The lathe has two dials, the cross feed dial and the compound dial. Each line on the dial represents 1/1000th of an inch. There are 100 marks around the dial, making it 100 thousandths or 1/10th of an inch per revolution of the dial. In lathe work, the dial is often set to 0 and then locked in place with the set screw. The dial rotates separately from the hand feed wheel for calibration purposes. The compound dial can also be rotated and secured in place. The compound dial is used in most threading operations where only 3 or 4 thousandths may be taken off at one time, where on the crossfeed dial, cuts of 15 or 20 thousandths are not uncommon. All of the threading and most of the cutting will be done under the power of the lathe. The gearbox is what's used to control the feed rate or the cutting rate while it's under power. Not just one, but both of these levers are what determines your feed rate, and it's done according to the chart that's above them. The left handle corresponds to the alphabet letters above it, which are A through E. As you can see, there are two columns of letters. The column on the left is what you will use when the lathe is running in standard gear. Most cutting and threading uses these letters. The column on the right is not to be used or referred to unless the lathe is running in low gear. These are specific to a low gear usage. The letters are then read horizontally across the chart. The right handle corresponds to all the numbers, including the smaller numbers that are shown. The numbers are read vertically and they correspond to each slot position of the right handle. The handle position here tells us that the machine will cut a 7.2 thousandths of an inch off per revolution when using the power feed. Or cut 56 threads per inch when using the half nut lever. By changing the handles, you can control how much is cut off per revolution or the number of threads per inch you want to cut. Each position represents two options. The top number is what determines the threads per inch that you'll cut, while the bottom number determines the amount that will be taken off per revolution in thousandths. Before you can run a lathe successfully, you need to familiarize yourself with all of its functions and its features. It's a good idea to spend some time with the machine, turning it on, turning it off, moving the carriage back and forth, and working the levers and the dials so you can see how each one operates and how each one is locked and secured in place. For example, when changing the gearbox, sometimes it's necessary to rotate the screw drive for it to lock into gear. The same is true with the reverse feed lever. Oftentimes you have to rotate the spindle in order for the reverse feed lever to lock in place. And always make sure the machine is off when you're moving the handle on the collet. But move the handle a few times and get familiar with it. Learn the different directions of the cross feed and the compound when you rotate the dial. Many cuts on a lathe are not done under power, and so it's important that you learn how these features work. Safety is also very important. Loose clothing can get caught up in a lathe very easily, so roll up any loose sleeves and secure any loose clothing before operating the lathe. After cutting your material off, or when you're just starting a new project, a lot of times you have to come in and do what's called facing. What you're doing is you're actually just squaring up your piece of your material to make it easier to work with, or to drill a hole so that it can be countersunk for either a live center or a dead center. Facing can be done either manually or it can be done with the power feed. Once you have your cutter set at the right angle, the next thing is to check the height. Sometimes it's difficult to find the right height that will clean up the entire end. Although facing is a fairly simple procedure, it is a requirement on many projects that are done on the lathe. Cutting or turning is the term used when you're cutting a part down to size. While this lathe is capable of making deep cuts in the 60 or 70,000 range, it's not a good idea for a beginner to start off that way. It's better to start off with cuts around 10 or 15 thousandths until you become more familiar with the lathe. Before making any cuts on a lathe, the clearance needs to be checked between the part and the cutter and the lathe itself to make sure that there is enough room for the cut that the operator is wanting to make.
Plenty of clearance there. There's no clearance here for the cutter to get in and make the cut. Have to use a narrower cutter.
In this case, the cutter was changed to fit the need. Many cuts are started by doing what's called scoring. By scoring the material, you can set your dial and then take off however many thousandths you wish to take off. Using the power feed is more consistent and produces a much smoother cut. When running at high RPMs and a slow feed rate, a smoother finish can often be attained. Parting is when you're using the lathe to cut a part off before you take it out of the machine. This is a holder that fits onto the tool post, and it's specifically designed to hold a parting blade. Parting blade should then be squared up to your workpiece to prevent bad cuts or to prevent damage to the cutters themselves. Secure the carriage by tightening down the carriage screw. The power feed is used in most parting operations. Parting is done by using a combination of speed or RPM and the feed rate of a cutter. Applying oil will help the cutter in most cases. When the feed rate is adjusted properly and the RPMs are consistent, the combination can make for a very quick cutting across the part. Oil is often reapplied during the cut. When the combination of speed and feed isn't correct or balanced, the part may begin to chatter like this one has. However, this was corrected by leaving the feed rate intact and lowering the RPMs. On the other hand, when the RPM is sufficient and the feed rate is not, the part may jam. Through trial and error, you should be able to find a combination that will work best for you. Threading is one of the operations that can be performed when using a lathe. And most threading operations cut the threads going from right to left. However, many threads can be cut going left to right. This is done by moving the cutter to the opposite side of the carriage and reversing the spindle direction. A groove is often cut and is used to be a starting or a stopping place when threading. Set the gearbox according to the threads that you're wanting to cut. If the compound is not already set on 30 degrees, then set the compound on 30 degrees before you begin cutting any threads. Most threads are typically a 60-degree thread, and threading is done by cutting 1/2 of the thread angle off at a time. After setting the compound, the cutter must be squared up to your workpiece before you begin. After a small scoring, both the crossfeed dial and the compound dial are set to 0. After the dial is set, then turn the dial about 3 or 4 thousandths to make your first cut. Engage the half nut lever to begin your first pass. When you have cut as far as you want, then disengage the half nut lever. It will take several passes to cut the threads. When starting from the outside, the process is the same. Score a line, set your dials, and start threading. Change the dial about 3 to 5 thousandths for each pass that you make. Having a nut close by is a good way to check your threading. And as you can see, this one is too tight, so more cutting is required. A couple of passes later and the thread will work just fine for this project.